And then we're going to propose solution. Okay, we're going to show that. So here it's going to be like, we're going to look at the externality problem as missing market problem. What market that is missing? So we're going to think that the market that is missing is the market for contracts that contingent on spot market price itself. So remember, the problem comes from the fact that what I can do today depends on what the price is going to happen tomorrow. Before in Prescott-Townsend or in the usual competitive market or competitive equilibrium, agent cannot contract on that price. Well, in the first best world or in the complete world, in the perfect world, we don't have to. Even we don't do that, everything is fine. Okay, but in this world we have to, because that causes externality. So we would like the agent to be able to contract on and say, okay, here's my good, and I would like to buy a contract that give me this compensation, and also give me the right to buy and sell the good at this price.
Isn't that an option?
I mean, it's a bit different, because option is like you may not exercise, right? You may say, oh, this I don't like this price, I'm gonna walk away. So here it's gonna be more restrictive because it's gonna be binding. So, and there's gonna be an important assumption on that. That once you contract on this price, you have to stay with it. You cannot say, oh, I don't like this price, now I'm going to walk away. Okay, that is going to be a key assumption. I mean, we can discuss on that. But it's a bit different. Okay, and we first show that in our other paper, which is deal with more directly to the crisis, I mean, not really crisis, but related to the crisis, because we deal with collateral and default in that paper. And we apply exactly the same solution. Okay, that's the first paper that kind of introduced this market-based solution. We call it market-based because we allow agent to contract on that, and there's going to be prices for those contracts. So it's going to be market institution. It's not like taxes or government intervention or anything. Okay, and just for computation, once we solve this problem this way, somehow examples show that now it's possible that, and it's optimal for the market to segregate agent into different price islands or exchanges in such a way that some group of people will trade with each other at one price, the other group may trade with each other at different price. That's why that assumption that I talk about, that you have to commit to the contract, is kind of binding. You cannot move away from, okay, I don't like this price, I'm going to move to the other exchange and buy at different price. That's not going to happen. Okay, we're going to assume that is impossible. Okay, and that's because it's possible to have a couple islands or a couple exchanges. So here is the plan of the talk. So I'm going to go briefly to the basic environment to tell you exactly what private information means. And then I'm going to present you Prescott-Townsend economy. So this is going to go in detail a little bit because it's kind of the building blocks for what we do. And then introduce retrading. Okay, and then we talk about what externality is, and then present you the solution. And I'm going to spend a little more time on example too. I mean, both to show you how the model works, and also maybe there's something in terms of computation that I would like you to see. Maybe you can give me a quick reaction. And if we have time, maybe not. I'm going to tell you about liquidity shock and tell you some discussion about the assumption I just made. Okay, any questions? You should feel free to ask. Okay. Okay, so here's the economy. Economy is very standard. So here's kind of a one period economy, or one period with two sub periods. Okay, first you start your life, and everybody start their life and sign contracts. Okay, that's what we call contracting period. It's just the period that you can sign ex ante contract. You can decide what you want to do. You decide your plan. You say, okay, I want to do this if this happens, blah, blah, blah. And then everything realized. Okay, there's going to be two goods because we need to retrade. Okay, if we have one good, the retrade doesn't matter. So that's why if you have one good, Prescott-Townsend just work fine. Okay, there's no problem with that. And now we assume two good. You can assume more. And we assume that there's a continuum of ex ante homogeneous agents. So here, just to make things simple, they assume that everybody look alike ex ante. When the economy starts, everybody just look the same. Okay, have the same ability, everything is the same. and just average the mass and normalize as 1, and give no endowment to no one. Okay, everybody gets 0 endowment, just for simplicity. Okay, you can have endowment that's gonna just add to the utility, doesn't change anything. And homogeneity also implies the utility is the same, so it's easy. So the utility depends on C, okay, consumption of good 1 and good 2. So today you're gonna, I shouldn't say today, tomorrow, but first you're gonna start to work, you're gonna put action or effort, and then output realized, and then you consume. Okay, you consume 2 goods. And we're gonna assume that everybody would like to consume both goods, so that means that in either condition, make sure that you don't want to have 0 of either one, okay, just for simplicity. And then A is going to be important. A is what we call action or effort. I mean, I use A because now I'm thinking more like, okay, let's think about action. So now you can imagine that you can put this model into like investment and investment firms that they take risky action versus non-risky action as well, right? There's such thing happen too. It's not just in village economy that you think about effort that people go to farm and work. It's more general than that. And once you take the action A, the production will tell you that here is, if you put A into the production, this is the probability that you're going to get output Q. Okay, Q is also a vector because now you're going to produce 2 goods. I mean, it doesn't have to be. I can have one technology with 1 good, the other technology with the other good. I mean, it doesn't matter. But just to simplify the notation, let's assume that once you take action A, you get the output Q with the probability Q. So F is, with probability F. Okay, and the F is a probability, so sum of F over all that possible output is going to be 1. Okay, and here we assume that all the set for so Q, A, and C are finite. So that when we put in a computer, it's just easy. Okay, you can deal with the infinite or continuum set using Prescott-Townsend technique later, but that's just for simplicity. Okay, we're going to grid up Q, C, and A. So the key point is, here we have moral hazard because we assume that A is private information. So here I'm going to assume that when you take action, nobody can see it. Okay, nobody can verify what it is. You just take it by yourself and you do it because that's the best for you.
Why would anybody else worry about your action? There is no principle here, is there?
No. I mean, principle is just, you can imagine that here is like, you have your household firm, right? You do it in the household, but you want to buy a contract from the market, maybe banks or exchanges, and they never come to your house and look at how hard you work.
So the market acts as a principle, and you're making,
yeah,
okay.
Yeah. So we don't need a principle here because there's a market that kind of trade the contract for you. So a principal agent problem is kind of partial equilibrium notion of this. So that's why I think it's important to say that Prescott-Townsend is kind of the first one who bring this kind of contract theory into general equilibrium. Because now we don't really need to talk about principle who decide this. The market is kind of tell you bunch of contracts that are available, tell you, okay, here's a contract, here's a price, which one you want. Okay, but the contract has to take into account the fact that A, that the contract tell you to do is private. They have to make sure that they make you work as they want. Okay, so that's the key of private information problem here. The market or everybody else cannot see how hard you work, so the only way you can sign a contract is to go through those contracts, and the contract has to take that into account. Okay, and that is standard moral hazard problem. And it's the same thing if you have liquidity shock. Liquidity shock is like, oh, the shock hit you today, and nobody knows what the shock is. Of course, you might want to claim, I need the money now, but nobody knows exactly, right? That's why that's also private, so it's kind of similar.